and today I'll wait until 7:02 to start. But by the title, you can tell today we'll be learning about animal systems. So it is more applicable to your current knowledge of biology. And you can also probably see a lot of this, maybe not see, you can understand when some of these things are happening within you, which makes it a lot more interesting. Okay, we're gonna get started. Animal systems, yes. So today we'll be talking about the immune system and the cardiovascular system. The immune system is like your white blood cells, your defense. Cardiovascular is your heart, pumps blood. So the immune system is often associated with something called the lymphatic system. And the lymphatic system is essentially like, we all know that we breathe in oxygen because our cells need it, right? So you inhale the oxygen, it goes into your lungs, to your blood, and it is now delivered through your blood vessels into your tissues, right? And when there is that like gas exchange, what happens is some of the plasma, which is like the fluid that your blood cells float in, leaks out of the blood vessels and goes into your tissues as well. So the lymphatic system is essentially like drainage. It takes all that leaked plasma and puts it back into the blood stream every day. And that's kind of like why, well, if you didn't do that, you would probably die and you would have a lot of like fluid accumulating everywhere in your body. So that's not good. So it's great that we have that. And what happens is the reason that it's associated with the immune system is because it's already such a small system that a lot of people don't like really consider it as its own animal system to begin with, or like body system to begin with. But also, while the fluid is being drained back into the bloodstream, there are there are filters in which you'll have a lot of white blood cells ready and stationed, and they'll kind of clean this fluid like, okay, there is a bacteria here, so let's get rid of it. Or there is something that we don't want, and that way you have nice filtered blood. So what you may notice is sometimes if you get a fever, you'll have your neck a little inflamed, and that is because you have lymph nodes like right here. I don't know if you can see me, but like near your neck area. And what happens is when you have a fever, obviously your body is fighting some type of pathogen or foreigner, and there's usually more white blood cells that enter these lymph nodes, and they're filtering more, attacking more, and that is why you see that like temporary inflammation. Sometimes your doctor also will check your lymph nodes, make sure you're doing okay. There's also lymph nodes in like near your armpits and near your groin. Those are like the main three. And there's more all over the body too. But onto the immune system, woohoo! The immune system, we're not going to be covering like specific types of cells and what exactly they attack, because that requires just a simple Google search. And there's not much explanation involved. And I don't know like if you're ever going to see that tested very often. So something that is a little more difficult to grasp are the types of immunity. There are two main types of immunity, and they're basically, you can categorize them into non-specific and specific immunity. Their synonyms are innate and adaptive immunity. So non-specific is innate. And essentially what that means is, I'll go through it. So these are the different parts, everything in bullets are the different parts of our non-specific innate immunity. So okay, you also have different barriers of defense. There are three barriers of defense, and the first one is like very physical. So you can imagine your skin is a physical barrier of defense, right? If I somehow like threw a fluid contaminated with bacteria at you, I would hope that like your skin is there to protect it from going inside of your body. Now, of course, if you have like a cut in your hand, there is a greater chance that it will enter your body, but on a normal basis, you don't have many cuts in your skin. And for areas such as like your eyes, your mouth, your ears, your nose, there are also mucous membranes because like it is a hole, right? My mouth, your mouth, anyone's mouth goes like directly into your body. So even like not only in these openings, but also like through your digestive tract, you may or may not know that you have mucus. It is not necessarily gross associated with like nasal mucus, but it is a substance that allows you to kind of fight off anything that may have entered into your body. Even like stomach juices, which is very, very acidic. pH of 2, I believe. Is it 5? You have a very low pH in your stomach, and that is also used to kill off some bacteria or foreign substance that you shouldn't have in your body. And then moving on to the second line of defense, it is like more than physical barriers, but nothing too specific. So for example, we see inflammation here. Inflammation can be in response to literally anything. You can stub your toe and you might notice your toe is inflamed. You can have a fever and you'll notice like your lymph nodes are inflamed, right? So it is a very general response to a lot of things that can happen in your body. Phagocytes are basically things that eat something else. So for example, a cell titled a macrophage is a commonly known phagocyte, and basically what it does is, I can draw it out. Annotate. Here we go. Okay, so we have our, let's play into classical, right? Bad guy, bad bacteria. This is actually, I just drew a virus, but pretend that's a bacteria. And now you have your macrophage, which is like this, right? Actually, macrophages are really, really big cells in comparison to a lot of other white blood cells, which is cool. Oh, sorry. So what it does is it essentially like, it has pseudopods, I believe is what they're called, and they like wrap around this guy like this. And then like phase 2, after wrapping around, it'll keep on wrapping around. You have this macrophage, and the macrophage has now eaten the bacteria. Yay! And then it'll digest it and lyse it and break it down and kill it. And that is the goal, right? You don't want bacteria in your system because it is not good. So that is how phagocytosis works. There's also dendritic cells, which are phagocytes. There are a few more cells who do the same thing. NK cells are natural killer cells, which is like a really funny name, interesting name. Natural killer cells and interferons are used when fighting off viruses. So there is a very common virus going around a little too quickly and a little too commonly, right? The COVID virus. And if you were to be infected with COVID, you will likely have higher NK cells and interferons that are working to fight against this virus. And then there's a fever. All of you guys know, I have a fever. That's typically associated with like higher temperatures, maybe you're sweating. And the reason for this is like the increase in temperature is because you have a lot of like blood rushing to the area of infection. You have a lot more, because when there's more blood, there's more white blood cells. Also, there's an increase in heat because I think it helps the, actually, never mind. I'm not too sure on that, so we're not gonna say that. But yeah, typically fever is associated with fighting things off, and it is a non-specific response. Then the second type of immunity is called adaptive immunity. I said it was a specific immunity, and there's basically 2 main cells involved. There's technically 5, but we're going to talk about the 2 cells that are involved, which are B cells and T cells. The reason this is called, so more specific, let's talk about that first. This is a more specific immunity because it fights off specific cells. So you may know like how a vaccine works, right? You have, well, this isn't, okay, we can pretend it is. So say you have some weakened bacteria injected into you, right? Your body's fighting it off and now it has memory. And what happens is the next time you have this specific bacteria in you, you use that memory to have a faster response. And that's like the goal of a vaccine, right? You fought it before, you can fight it again because you have memory. So B and T cells are for very specific pathogens. So if you have X virus or X bacteria, you're going to have this type of cell come in. So that is why it is specific. It's not a general response. Something interesting is so all of your like blood cells are made in your red bone marrow. Something happened? Okay. Can you guys hear me? Could you like text in the chat if you can hear me? Okay, thanks. Thomas, you rock. Did someone raise their hand? I have no idea how I can, but you can unmute yourself. Is that allowed? Amy, your hand is raised. Okay, if you have a question, I think it is easiest to type in the chat because I think there might be a setting that doesn't allow you guys to unmute. But yeah, I'm reading the chat. Thank you guys. All right, I don't know what happened. My screen became weird for a second. Okay, so yeah. What cells do chickens have? Chickens? Like, are you asking what like? Okay, I'm gonna assume you are trolling, and we're going to move on. All right. So within the adaptive immunity, you have two different, I guess, types of responses. There is a humoral response and cell-mediated immune response. Humoral immune responses use your B cells and cell-mediated use your T cells. If you guys have ever heard of antibodies, antibodies are used to fight off different bacteria, foreign substances. Antibodies are made by your B cells. Right, yeah. So antibodies are made by your B cells, and that is why B cells are so critical. Yeah, they kind of, so my screen, the like zoom bar is covering it, but if you look at the bottom right, you see the little Y-shaped things. Those are antibodies, and basically what they do is they find whatever you have in your body, they kind of like mark it, and that allows for more cells to come and attack them, and then goodbye. And what's cool is like plasma cells can make many. Plasma cells are, I don't know if mature is the right word, but B cells can become plasma cells in response to a certain foreign thing in your body. And these plasma cells will secrete many antibodies. So yes, so when you look at immune responses, you start with your first exposure, right? You have an antigen that is in your body. And there are different things, I guess there are two pathways it can go on. One is the antigen is like a B cell that matches with it, comes across it, and it becomes a plasma cell, creates antibodies, destroys the antigen. Or what happens is it can be engulfed by an antigen presenting cell. And there are three of those. Let me write that out. All right, antigen presenting cells are macrophages, dendritic cells, and actually the third one is a B cell. So these guys, oops, there we go. No, okay. That didn't work out. You can kind of read it. But what they do is they can now present the foreign substance that they've kind of eaten up, and they have like a certain marker to what they call a helper T cell. There are two different types of T cells, I guess three. So just follow me with these terms, and you can look back on a diagram and it'll make more sense the more you look at it. So you have an antigen presenting cell, which are one of these three, who are like, hey, I found this thing. And then the helper T cell will be like, oh my goodness. And then it'll decide whether to present it to a B cell or a cytotoxic T cell, and it'll go down this path. And the great thing here is you can see memory is, okay, so someone asked, what is the hardest topic in 9th grade biology? Hardest topic? I mean, I guess it like depends on the person, right? 9th grade bio. I can't see your name, but do you have the one I got lowest grades on? I think I had like hundreds across 9th grade bio, but I think I had the least like familiarization in like ecology type topics and natural selection. My 9th grade year got like cut off because of COVID, and I think that's like what we were like going into. So I would say, I guess that like cladogenics, but it's not, honestly. Okay, I think what I saw other people struggle on a lot was like chemistry related stuff in the beginning of the year, just because it is hard for some people to grasp the concept of like how elements work together to form molecules and like what does each of them do. I think the first class I talked about saturated fats and unsaturated fats, so I remember those were things on one of our first tests. But I also like have a lot of the slides that they used in 9th grade bio before. So what I could do is on the Kid Teach Kid website, there for all the subjects, they have different resources available, including like these lectures. So I may be able to upload some of those if there's a specific subject that you think you would need the most improvement on. So if that is the case, let me know. Or I can email it to you as well. But again, like I would assume if you're in this class, you have some type of interest in biology. And if that is the case, you should do well in this class. It is not hard, in my humble opinion. You'll do good. Yeah, I think that would be, for me, it would be ecology related stuff because I've done the least out of school studying on that. But that's like, depends on everyone. So yes, you have the difference between B cells, T cells is you have these plasma cells, and what they do is they fight against extracellular pathogens versus cytotoxic T cells fight against intracellular pathogens and cancer, which is obviously something of importance you should have immunity against. So yes, I hope that made sense. It is not complicated at all, but I think it's really great that you know the difference between these two pathways. And yeah, that is all that I have for immune system. Now we will talk. Okay, does anyone have questions on the immune system before let's get rid of this guy. Oops. How do you hello? There we go. All right, it's gone. All right, I'm going to assume no one has any questions. So we're going to move on to the cardiovascular system. So technically, the cardiovascular or the circulatory system consists of like the heart and also blood vessels and blood. I primarily focused on just like the heart and something that is called the cardiac cycle, which is like the biggest thing about this system. The reason that you were alive. Cardiac cycle is great, and there's a lot of concept on it. Blood-related stuff, it is not of great importance. And, well, it is, but not like learning-wise. And relating to blood vessels, the only thing... Okay, I'll go into a small mini lesson about blood vessels. So you have arteries and veins. Arteries go away from the heart, veins go toward the heart. Typically arteries carry good blood, but there's a couple that defy that, and typically veins carry bad blood, and by bad it means deoxygenated. So there are technically 5 blood vessel types. You have that is an artery, and then you have an arteriole, and then you have your itty bitty capillary, and then you have a venule, and then you'll have a vein. All right. So, important things to note. Arteries are more muscular than veins. They also have more elastin, and this is because when your heart pumps blood out, it is with an extremely high force. And if your blood vessels were if your arteries were very narrow and constricted and they didn't expand, you can understand why that would be a problem, right? Your blood vessels will probably rip a lot, or the blood might go back into your heart, and obviously you want it to leave so you can have more oxygenated blood going to your body. And so blood will leave through arteries, right? And they're also like muscular because it helps with like allowing it to flow down to everywhere else in your body. And then as you approach, so say I'm looking at the capillaries in my hands. As I like get closer to my forearm and my hand, my arteries become smaller, right? They branch out and they become arterioles. So you have your big artery, which has now branched, let's say, into 3. So they're all smaller vessels, and they're called an arteriole. So arteriole. Which then becomes a capillary, and capillaries are like one cell thick. You know how small cells are, so you can imagine a blood vessel that is the width of one cell, super duper thin, and that is how that is how nutrients can leave, bad stuff can enter, and then oxygen, carbon dioxide, gas exchange occurs. Then you have, right, so I do purple because blue and red makes purple, and this is like a mixture of oxygenated and deoxygenated blood. Then capillaries, and then they become 3 to little venules, and then a vein. Important thing about veins is veins have valves, which is not seen in arteries, and that's because veins, so you can imagine your foot. Your foot has blood. It needs to go literally against gravity, and let's say you're 6 feet. I would say your heart is around 5 feet. So your blood has to travel 5 feet upwards against the force of gravity, which is like quite a task, right? So these valves essentially prevent backflow. So what'll happen is, okay, I'm going deeper into this than I planned. There is a skeletal muscle pump. So let us erase this. So this is, okay. So this is your muscle here in your leg. This is also your muscle. And then between your muscles, you have a vein. We have a little valve. So whenever your muscles contract, they're going to push inwards, right? And when they push inwards, this becomes more constricted and blood will shoot upwards for a little bit. That was a horrible arrow. Okay. Blood will shoot upwards. And then what happens is your muscles are going to relax, right? So you want these valves to now close so that whatever blood went up stays up. And then it continuously follows this. It goes up and up and up until it reaches the heart, and the cycle continues. So that is the stuff about blood vessels. That's really anything you're ever going to need to know. Yeah. There's also like some mathematical equations relating to viscosity and blood resistance. You're never going to see it in school though, so all good. So this is the cardiac, well, this is the heart. I'll go into this. This is the cardiac cycle. It may look a little overwhelming, but it is like the coolest thing you're ever going to learn ever. We're going to start with something simple. I believe everyone here has watched a movie in which there was a patient in a hospital room and they have their little heart rate showing and then it flatlines, right? I'm sure most of you guys have seen this. And so the heart rate itself, yeah, see, we all seen this. It's very classic. So this is one heartbeat. It is called an ECG wave, or it's an electrocardiogram. And typically when you see it in movies, it is a lot faster. So it'll be, oh, hello. Oh, that's not supposed to happen. Can you guys still see the right screen of like the cardiac cycle? Yes. Maybe. Okay, I'm gonna stop sharing, and I will share this with you. Okay, can you see it now? All right. Okay, sorry. Let's go back to our ECG wave. This is it. Typically in movies, when you see it, it is a lot faster. So you have your P, Q, oh God. Okay, that was kind of ugly, but it's like that and it's continuous, right? And so you can kind of see this label. So this is your P wave, and then this is Q, R, S, T. I'm not sure why it's named that way, but that is how it's named. Those are different points on the ECG wave. And if you ever become a cardiologist, which maybe someone here will become, what you look for whenever someone has like a heart deformation, or when you're like speculating this, you look at, okay, someone could have a prolonged, or maybe they'll have two P waves. So P wave, QRS, T. Then you'll go, okay, there is a problem. And then you'll go, okay, what happens at the P wave? The P wave is here. And that is, so we'll go over the cardiac cycle and you'll be able to associate different parts of the ECG with different things that the heart does. And that is like what you look for, which is why ECG waves are really important, because it can show a lot about the heart without like an invasive procedure yet, or like something complicated or that requires imaging versus an ECG. You just have to like put on like, I think 12 electric LEDs on you. You're all set. So let's first look at, you might know like how you may have heard of the lub dub sounds of a heart, where it's like lub dub, lub dub. And that is like, you see S1 and S2 at the bottom. S1 is lub and S2 is dub. Dub. And these are basically the sounds that are created whenever a valve in the heart closes and there is some blood backflowing. So if we look here, lub, okay, let's look at this diagram first. So you have blood, let's write in black. You have blood entering. Do you guys remember which type of blood vessel goes towards the heart? Your choices are artery or vein. Yeah, vein. So your vein brings blood to your heart. So you can see this thing called pulmonary vein. There are four main entrances. It's in red, and they all come into the right atrium. So this is all deoxygenated blood. Then what happens is both of your atria, your right and left atria, contract at the same time. So we're gonna get to what type of blood is here, but so we'll just focus on the right atrium. Then these atria contract, this valve will open, now blood is here. Then both ventricles will contract, and then the blood here will go from this, and then it'll go to the lungs. Pretend that is a lung. Then when the blood is oxygenated, it'll go from the lung. Wait a second. Oh, no. Sorry. Just like erase everything I've said. Oh my goodness. All right, that did not happen. We're gonna backtrack. Blood enters from the body through your vena cava blood vessels. There's a superior one here and an inferior one here. Oh gosh. Ignore the pulmonary veins right now. The superior vena cava drains from your head. So any blood that is deoxygenated leaving your head is going to go downwards, right? Any blood that is below your neck is going to go upwards, and both of the vena cava drain into the right atrium. Then it goes to the right ventricle, then it leaves through the pulmonary artery, goes to the lung, enters the left atrium from the pulmonary veins, goes to the left ventricle, goes to the aorta, and now it is in the body. So that is like the general flow of blood. And what happens is your atria contract at the same time. So whenever, all right, this is a difficult concept to grasp and explain. So let's move this. We're gonna look here. No, we're gonna stay here actually. So whenever you can imagine, you want your atria to fill to its fullest, kind of, before it flows into the ventricle, because you don't want to waste energy contracting the atria if there is not enough blood in it. So what happens is you have this is called the tricuspid valve, and this is the mitral valve, which is sometimes called the bicuspid valve. The reason behind these names is the tricuspid valve has 3 flaps. The bicuspid valve has 2 flaps. And if you know anything about English, tri means 3, bi means, I guess it's not English. Word origins. Bi means 2. Anyways, so you have blood filling into the atria, and you have these valves closed. Simultaneously, your ventricles are going to empty. So these valves will be open. Yay! Open valves. And during this time, both ventricles will contract and blood will be ejected. So another good thing about these valves being closed while the ventricles are contracting is blood will not go back into the atria, right? Because from the atria, blood goes to the ventricles. You don't want it to go backwards because that defeats the whole purpose. So these valves remain closed. And while they're pumping, the atria are filling. Now the ventricles are running out of blood, they're getting empty. So these valves are going to close. These are going to open. And now you have the atria contract, and they put blood into the ventricles. So the lub-dub noise is from the sound so first what happens is your atria empty into your ventricles. Then these valves will close. Then your ventricles will empty into their blood vessels, and then these valves will close. So the lub is created when blood is emptying this way, but these valves are closed. So it's going to rebound backwards. And that sound of blood hitting and bouncing back makes lub. And then here it'll happen again, and that is dub. Oh, sorry, here. It'll go from this to there. That is the dub noise. Wow, this is a very messy screen. Did everything so far make sense? It's type a question in the chat if something did not make sense to you. Okay, I'm going to assume everyone has 100% idea of what is happening so far. And now we have covered the bottom 2 rows of this very complicated diagram. We understand the heart sounds and we understand ECG waves. kind of. Now we're going bottom up because it makes the most sense that way. So left ventricular pressure, that is the black line that has this huge, just like whoosh. Yeah. Oh, also you can notice the top says diastole and systole. Okay. I have a friend who says systole and diastole, but I'm fairly certain it's systole and diastole. Whichever one they are, just go with the flow. Systole or systole means contraction, and the other one means relaxation. In this case, the diagram is referring to the ventricles. So when the ventricles are relaxed, that is when blood is filling into them. First, and then they're contracting, and then they're relaxed. So the pressure, okay, you see this like slight increase here, right? We're going to start from this point here. So the mitral valve opens. What is the mitral valve? That is the bicuspid valve here. The reason also that this is focusing on left ventricular pressure is because the left ventricle has an immense amount of pressure because it is pumping against like everything. It is going to your whole body, right? Your right ventricle does not have as much pressure because it's only going to your lungs, and your atria have like no pressure almost compared to the ventricles because they're only pumping like into the ventricles. So your left ventricles have an immense amount of pressure, or ventricle, because it is pumping a lot of blood against a lot of pressure at a great speed. So when your mitral valve closes, so mitral valve is now closed, why do we think the left ventricle is increasing in pressure? Does anyone have any idea why the valve closing would lead to an increase in pressure? It might be a tricky question. Oops. Okay, I will take that as no, we do not know, and that is okay. So you might notice it also says aortic valve opens. So during this time period, that would mean both of those valves, pulmonary vessels, are blocked temporarily. No. Okay, blocked. I don't think your pulmonary vessels are ever blocked, because if they are blocked, no. So those are the atria. Your blood fills the atria of the heart. It's going the wrong direction. Okay, so pulmonary vessels, or your veins, right? They enter here, and these like holes, I guess, are always open. Yeah, I don't think they ever close. Your atria are always filling, and there's never a time in which blood is not allowed to enter from the body into the heart. There's constantly blood will be flowing here, because if the pulmonary vessels are blocked, like I'm assuming any pulmonary vessels, either you will like run out of oxygen, or the ventricle, the route to the ventricle. Okay, I think I understand. Yes, so kind of. Okay, you're right in a different sense. So basically, correct. One thing is, these places will constantly be filling, and that will lead to an increase in pressure in the atria. But whenever you have this valve closed, and I also mentioned just now that this valve is also closed, the aortic valve is closed, there is a period called isovolumetric contraction. So if we break that down, iso means same volume contraction. So no blood is leaving. However, the heart is starting to contract inwards. So you can imagine, like, if you know Boyle's law, which you may not know, but that is the relation between pressure and volume. Actually, yeah, so when volume is decreasing, pressure is increasing. So you have this large building up of pressure, and this is like strategically planned because when the pressure is increasing so much, then whenever the aortic valve finally opens, you can like push all of that blood out at a really great speed and flow rate, which you need when you're like going towards like literally your feet. You have blood that is going from your heart to your toes, which is such a great amount of distance. So that's what like this large jump in left ventricular pressure is because you have your heart, your ventricles are contracting and both valves are closed. And then your aortic valve opens, yay, and blood leaves the ventricles to the body. And that is why for a certain period of time it increases and it starts decreasing. Because like there's no more blood. The blood is all gone. And then your ventricles are contracting less. How does a heart do so much stuff? Literally, our bodies are so cool, Leo. I don't know. That is a great question. But it is able to do all of this, right? I feel like it is sometimes difficult to process. It is difficult to process how much our bodies do, it is amazing. That's why biology is a really fun topic. I hope you guys are enjoying this class. If anything, we're just talking about stuff that we think is interesting. So then the aortic valve closes because now you have no more blood to eject, right? So if we go back, the aortic valve here is now closed because like at this point, there's so little blood and little pressure here. Blood will end up coming back this way. And we don't want that because, you have a lot of blood in your ventricle and all of that is pushed into your aorta, which is the first artery any blood will go to. And so at one point, what'll happen is the aorta is going to have more pressure than the left ventricle because it has all of that blood, right? And I don't know which law says this, but logic will tell me something goes from high pressure to low pressure. So we don't want that backflow. And that is why this valve will close. And that is where we get our dub noise. So that's what happens here. Oh, I hate how it doesn't erase. Yes. And then your mitral valve opens here. And your mitral valve is the bicuspid valve in this diagram. And that is when you're now blood from the left atrium is now entering your left ventricle. And so pressure is going to gradually increase because there is an increase in blood there. We're going to ignore the right atrial pressure because I don't think you'll ever need to know this. Like maybe like if you're planning to pursue medicine, maybe you'll learn it in like med school or pre-med. You'll never need to know, like not even in competition science will you need to know, to my knowledge, about right atrial pressure unless you're competing in like heart competition where all they test about is the heart. But that is not a thing to my knowledge as well, so I made that up. The rest of this I've seen on like science olympiads, so I think topic rotation wise, maybe in a few years this is going to come back and you'll need to know this if you plan on doing that. And then the last thing is the aortic pressure. All you need to know, or all that you see here, is that aortic pressure increases whenever blood is ejected into the aorta, and then it decreases whenever the valves close. What are S1 and S2? Wait, I think I missed these questions. S1 and S2 are the heart sounds. So lub is S1, dub is S2. Yeah, I kind of went over this. Is there anything you're still confused about that? Also, I'm sorry, Sean, I just saw that. What do you mean by back pressure? Is that when I was talking about backflow of blood? Okay, we'll come back to that whenever you guys answer that. Yes. So you see here that the aortic valve opens. And when the aortic valve opens, the ventricle, hello? Okay. When the aortic valve opens, the ventricle will eject blood into the aorta. So naturally, the pressure will increase, and then the blood is flowing out of the aorta to the rest of your body. So gradually, pressure will decrease. Oh, the dicrotic notch is actually interesting. It is the backflow that I was talking about. At one point, the backflow will be so great, the blood leaving will increase in pressure. So blood is here leaving, entering the aorta, it's going, and now it is starting to leave, right? And the aortic valve closes. So now any blood that was to leave the ventricle has already left. And what happens is some blood will rebound backwards, like I said, to make the dub S2 noise. And when it's like re-entering, so it's, okay, so it went from your ventricle into the aorta, right? That happened. And then this valve closed. But now I mentioned earlier, the pressure in the aorta is going to be so high. It's going to be lower towards the ventricle. So the blood is going to come back. It's going to hit this valve and it's going to go this way. And like the backflow is so strong and it has such a high pressure that you get this sudden increase, and it's called the dicrotic notch. Right. So this is a greatly, very much complicated diagram. If you were able to follow with everything I said, like go you. That is amazing. There's a lot of stuff to this. And like, but if you got this is basically the entirety of anything you'll ever need to know about the heart for the most part, excluding like specific parts of the heart. For example, like chordae tendineae and just like diagram labelings, but that is not of too importance in my opinion. So what I like to do for these classes, and if you don't like that, like I can switch it up, but there is anatomy and there is physiology. Anatomy is like your eyes are here, your hair is here. But physiology is your eyes function because of rods and cones, which open due to these channels. Or like, again, anatomy would be, this is the right atrium, this is the right ventricle. And then the physiology would be like, this is how it contracts, this is why it contracts, this leads to that. And I think physiology is significantly harder to understand sometimes when you're learning about the body. So I thought it would be better if I taught physiology. And if you're more interested in the anatomy, it is a very quick Google search and you can learn very simply. Like again, the types of white blood cells. That is not something that requires a lot of thinking. It is just memorization. And I don't want to waste your time teaching you something that you could literally just search up. I think it was very hard for me to learn the entire cardiac cycle by reading it from a book. And it would have been great if someone could have explained it to me, which is why I'm doing that now. But if we do not share the same thoughts on that, let me know. And then next class, I'll focus more on like diagrams and more trivial stuff. Should I make a poll? Can I even do that? Okay. Let's see. Oh, there's already questions here. Interesting. Okay, I cannot create a poll. Wait, sorry. Okay. The poll is like related to something for physics. And I can't change it. Yeah, so type in the chat or in the Q&A place if you would prefer anatomy or physiology, or you're okay with anything. Oh, also, if you guys like came to the last class, it was just a recording. So if you had any questions from there, now was your time as well. Yay, physiology. You guys are the best. Okay. Physiology is also more interesting. Yay. Yeah. Did you guys come to the last class? I don't know. I can't really see names in this. So I don't know if the people who come to every class are the same people. But yes, if you have any questions from then, let me know. That is all I had. I was just under the impression that you guys would have a lot of... Can I send the physics poll? I don't think I'm allowed to do that. I think this class has to be solely biology. Yeah, sorry. I don't think I'm supposed to do that. But it is just asking, like, do you like physics, essentially? Yeah. But everyone in this class should enjoy biology more than physics, right, guys? Maybe not. Yeah, but that is all I have for today. So if you have any questions, go ahead and ask. I guess if not, we can end early. Yeah. I'll stay here until 8. You guys can mull over your thoughts. Okay, wait, for those of you guys left, do you want to, if it's okay with you, could you type into the Q&A or into the chat what grade you're in? Because sometimes I'm planning a class and then I realize that I'm not sure if you guys are at that level or not. So that would be helpful when I'm creating my slides. 7th grade. It's exciting. Hey, if you're going to 7th grade, a lot of the stuff you're going to learn next year, if you live in Katy, is related to body systems. So you're going to be so ahead. You can teach the teacher, like, actually, I know about this stuff. That's going to be exciting. Maybe not. I don't think they go so deep. So you will be at a greater level than what the class teaches you. It's like basic animal biology. 5th grade. Wow. You are ahead of your time, William. Okay, so I'll definitely... Are you able to follow with us? I don't know if it's too deep. Okay, I'll assume you can. I'll also try to get those 9th grade biology slides up on the website. Or maybe I can just go through them next week. Would that be preferable? Do you want to learn more about animal systems, or would you prefer I just like run through as much 9th grade biology as possible? Okay, so you guys are junior high elementary. So maybe I should run through the 9th grade slides. Would you prefer that? To my fellow friends who are answering in the chat. My plan was to continue with animal systems, but I could just do 9th grade bio, at least like the beginning parts, give you a head start. Okay, we can do 9th grade bio. What I'll do before animal... Oh no. I could just like combine them and I can do the animal system slides from 9th grade bio. I believe, let me check. I saved everything. Did I save everything? Biology. Okay, yes, so there are body systems. It is very basic though. We could do some of it and then move on to deeper stuff. Okay. I believe that is all anyone had to say. So I'm going to end the Zoom now. Have an amazing July 4th weekend. I will see you guys next week, hopefully. And we will likely do 9th grade biology animal systems. Yes, sounds like a plan. I'll see you guys later. Bye-bye.